So a couple of months ago, a friend of mine had a heart attack because getting old sucks, and the docs popped a stent into her and sent her to something called cardiac rehab, which is a program the hospital runs where you go once or twice a week and take a bunch of classes in how to relax and how to eat more healthy, and they show you pacemakers and things like that. Mostly what it really is, though, is listening to a bunch of other people who've had cardiac events vent about how terrible other people's lifestyles are. It's kind of like traffic school in the old days when you actually went to traffic school and taught by a CHP officer, and everyone in the class would talk about how bad every other driver on the road was except themselves. So that sort of thing. Anyway, the other thing they do at cardiac rehab is they put you on a treadmill or an elliptical with a bunch of monitoring equipment to monitor your heart, and that's to get your strength back up and your fear of exercising back down. And my friend loved it. She was losing weight, and it was really the best part of the whole experience for her. But then, of course, the insurance company cut her off after 4 weeks or whatever, because America, the greatest healthcare system in the world, and she wasn't sure what she was going to do because she loved exercising on this thing. Well, it turns out she and her husband bought a used elliptical several years ago, and they keep it on their porch. The problem with it was that the controls didn't work. When you tried to change the resistance, nothing would happen. It seemed like a keypad problem, but we weren't sure. So she said, "Ward, can you come up and take a look at it and maybe fix it?" And I said, "That's great. I'll get another silly YouTube video out of it and satisfy my insane narcissism." So it's a win all around. And actually, that's what I did. And there's pieces of it here. I still haven't fixed it, but we're in process, so we'll see how it goes. I'm shooting this in the middle of putting the whole video together. Anyway, so I went up there like 2 weeks ago. Beautiful scenery. They have the porch overlooks the creek and the trees, so while you're exercising you can look out on all that. It's wonderful. And the first thing I wanted to do was decide whether the problem was in the motor itself that winds the cable that changes the resistance, or if there was a problem with the console itself. And we want to check the motor first because the console's perceived to be harder to work on. So to get in there, we had to take all the plastic off the bottom of it, and that wasn't too hard. It's held together with a bunch of Phillips screws, so those came right off. But then you need a specialized tool called a crank arm puller to pull the pedals off, and I didn't know this. I'm not a bicycle person, but I finally figured it out. So we had to stop that day, and then it was about a week later when I came back with a crank arm puller, and we proceeded to get inside there and do the diagnosis. I was thwarted last week trying to get this off because you need a specialized tool to do it. I banged the crap out of it with the rubber hammer, but it wouldn't come off. So I got one of these crank pullers, which I've never used before. I don't know if I've seen people use these on YouTube. I don't know if anyone's ever shown up close what it really looks like. Let's see what I can do here. So it's a threaded barrel on a very long inner threaded piece. So the idea is that this barrel screws into the crank arm. There's a really long thread. You see that there? So this screws into the crank arm, and then this goes in and through, and as you're cranking this in, and then it pulls the crank arm away. So let's try it and see if the darn thing works. Okay, so here we are. Here's the barrel. This is loose because I was trying to get this out to see if I could get enough clearance to get it off, but I couldn't. So anyway, this is kind of standard. These are called square shafts. So in theory, it looks like it's gonna fit in there okay. Yeah. Boy, that's kind of tight. Kind of want that down in there pretty good. I'm going to get a socket. Hang on. Well, I don't have a socket that's big enough, but I do have my headlight now, so I can kind of see a little better. So I guess we're just going to have to pray that this works. I can still screw it in, and I didn't bring any wrenches with me today either. That seems pretty. It's turning the crank now. All right, well now let's drive this in and see if it actually pulls it off. So it looks like everything is. Is this reverse threaded? or forward threaded? Forward threaded. Okay, the bottomed out there. Man, it's going, but it's tough. Yeah, there we go. Now it feels. How about that? Oh my goodness. Ta-da. Wow, that's great. And then we can finally get inside this thing. Of course, there's a power socket on this. So I took the other side off. It turned out to be kind of a pain. The tool didn't work as well. It was hard to get the threads going. And then I didn't even think it was turning, but it popped it right off after I goofed with it for a while. But anyway, now that we're inside, so this is the magnetic resistance brake, and then this cable here pulls the magnets closer or farther away from this outside metal ring that provides the silent, frictionless braking. And then the tension is driven by this little DC motor here. And the problem with this unit, as I said last week, is that when you try to adjust the tension, nothing happens. So the question is the fault in this motor, or is the control board up top not sending the electricity to this? And the word on the street is if you put a few volts into this, it should turn. And if you reverse the polarity, it should turn the other way and run this cable. So that's what we're going to try to do. There's an access panel around the back, and we'll take that off and see what we got at the back of the motor here. So this is the view around the back, and I stupidly didn't bring my little screwdrivers this time. I had them last week. Well, let's take this off and see if we can get some contact points we can goof with. There's also supposed to be a variable resistor in here that monitors the location of the motor and sends a variable resistance up to the control unit, so it can figure out where the motor is. That should have a constant DC current coming into it as well. So we'll test that too. Let's see what we got. I priced these motors and get new ones still, but they're like $100. And it looks like we have a little control board, but let's see what we got here. So at this point, let me just cut in for a moment with the schematic I drew later of the motor board you're looking at, because I think it makes it easier to understand. And there's several different functions going on the board. All the different colored wires come into this connection on the side, and that connector runs up to the console up on top of the post. These 10-wire buses, I guess, are pretty common on exercise equipment, given what I'm seeing on YouTube, and now that I'm actually reading about this stuff. And you can look at this divided into sections. This is one section, this is another section, this is another section. So the most interesting part was I thought that there was a variable resistor, potentiometer, that was telling the controller the position of the cable driving motor, but no, it turns out it's using effectively a little electric eye, if you're old enough to remember those. It's called a photo interrupter, and those are those little U-shaped pieces of plastic, and what there is an infrared LED that gives light off and excites the base of a transistor that I assume grounds this out and gives a series of negative going pulses to the controller up on top of the post. And one of them, the nearer one, it's a horizontal, is engaged by that little silver tab you can see hiding in the back there. That's mounted on the cable shaft. That only blocks the photo interrupter when the cable motor is wound all the way back. So that's how the controller can tell when the cable is wound all the way up. And then the other one is interrupted by this little black plastic doodad. It looks like a kinescope or something with the slots in it, and those slots go through this other photo interrupter and count the revolutions of the cable motor, so the controller can tell by dead reckoning how much cable has been let out once it winds it back to the 0 point. So that's pretty cool, and that's much better than a variable resistor because they never wear out. So this is this one section, and that's all powered by this VCC line that comes in here, and I'll talk a little bit about that later because this confused me down the road. The other sections on here, this is the motor control. So you run a little DC voltage on the white and green wires here, and I mean a few volts DC, and if you put the polarity one way, it'll run the motor one way, and if you flip the polarity, it'll run the motor backwards. So that's what the controller does. And then across that, you can see this little capacitor and resistor, which I believe is to keep motor noise out of the digital electronics. It probably also softens the transitions from forward to back and back to front. The controller also needs to know how fast the main flywheel is spinning to give you your speed and your revolutions per minute, and so it can calculate distance and calories and all that stuff. So they have what's called a Hall effect sensor, which is a little sensor that senses a magnet going by on the flywheel, and that's connected to the purple and yellow wires, and that signal is called RPM. And then at the bottom, this is not on the connector on the control board, but it does add itself to the bus going up to the controller, is the output of the AC adapter, which we in the trade call a wall wart because it's kind of ugly and hogs an outlet, and that's a 7.5 volt DC on the gray wire here, and this is the negative side of that. Okay, so I've clamped onto the motor minus and motor plus leads, and these are just grabbers that don't have anything on the other end except bare wire. And we will try to just use a big D battery here and put 1.5 volts into it and see if anything happens. Now let's try 3 volts in. Or yeah, put that up there. Yep. Let me try this. Let's see. That's plus. Probably doesn't matter. Hope this isn't too much voltage because the thing has a 7 volt supply. Yep. There we go. Let's run it the other way. I don't know if you can see it turning or not. Yeah, so the motor's fine. How about that? So unfortunately, I wasn't recording, but when I plugged this in, and the controller went beep, 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 and wound the motor back. I don't even think the motor was moving before. And then some sensors made it stop, so it seems to be happy. So I want to try to run the adjustment from up on the controller. So it's awful pretty here anyway, but down to the business at hand. I don't know if you can see this, and I don't really know how this is supposed to work, but we can do. And then this is supposed to change the level. Now that one's beeping, this one's not beeping at all, so it really kind of seems like we have a problem with this button. Since I know the controller is capable of resetting the position of the motor now. So that's okay. I can get this on the workbench and we can bypass that if we have to. So I'm going to go ahead then and take the console part home, and that involves removing these 4 screws to get it off this post. So here's with the 4 screws out, just for the record, and there's the harness going in. I got to remember those wiring colors. I'll take some pictures as well. And then these other 2 lines go to the capacitive sensors for your hands to make sure your hands are on the grips when the thing are running. Okay, so here we are with this thing back in the shop. I've cleaned some of the dirt off of it, and we're going to go in the back and take out all of these screws. I see this secondary connector here that didn't have anything in it. I'm wondering if that's a debug port. It might be interesting to kind of probe that and see if we can see a RS-232 transmitter going or something. But anyway, let's get this thing out and take a look at what it is. I don't know what we'll find in here. Oh, we seem to have a ground connection here to a post under here. I can't really see very well. I don't know if that connects it. I guess maybe grounds it to the whole frame of the device down the post, but I'm not quite sure how that works. Anyway, there we are, a little toroidal core to take noise off of the hand position sensors. It looks like a separate power supply board here. We'll have to see what that actually does. And then the keyboard stuff is hiding under more junk here down there, so it may not even be accessible. So I need to look around this thing and kind of figure out what's going on before you decide what to do next. So hang on. All right, so I've been looking around a little more. This ground wire just unscrewed from the case, and it does ground it to the post, so there's that. Obviously we have our buzzer, a big wire round resistor. I assume this is a varistor or SCR for the for turning the motor on and off. Got another one here. This is not a power supply board over here. Is that in the frame? Yeah. This is a sensor board for the capacitive switches that tell whether your hands are on the controls, and then obviously that converts it to, I don't know, some kind of digital input and sticks it in here. These long strings of solder joints are the display for the big LCD on the other side. This is the CPU. It's been potted, but it looks like it may be an MSP430, a TI part, which I have actually programmed in real life in the past. These are a couple of LCD drivers. So this drives the top half, this drives the bottom half. This is a little hex inverter. So unfortunately, and the display is on the other side of this board, which I may take up here, I don't know. Anyway, this ribbon cable goes to the keyboard, and unfortunately it's on the other side, and this is one unit, so it was laid in from the front. So now I'm thinking it's a pad with the electronics integrated into it, which is kind of a pain coming to this cable. So if I'm going to play with it, I'm going to have to figure out I'm going to have to decode the matrix here that's being scanned by the processor, and or figure out how to mechanically trick it out here, or electronically trick it out even. But that does mean that to get to that stuff, you have to go in the front, which is a pain. But as I'm starting to, well, I had a little screwdriver here, so I'm starting. Can you see this? So I started to kind of go in here, and it does look like this is glued down like a pad sitting in this recess, and it'll come up. It seems to be glued down. So what I'm going to do, I'm going to take the heat gun, not the heat gun, the rework heat, and just see if I can gently lift this up and out of here without tearing it to pieces. So we'll see. It's probably best to go ahead and verify that everything is really working with the control board before I continue that. So let's go ahead and do that. This is the board now out of its case. Yes, this definitely is an MSP430. This is not a any kind of tri-hack for a motor or anything. This is a voltage regulator, which I should know because we're talking about DC electronics, but I'm kind of stuck in the mindset from my electric blanket video, which uses switches AC, and if you haven't watched it, you know, you should. Anyway, so what I've done here is I've made these connectors to put power into this board. This is the jack that connects to the 10-wire bus that goes down to the power supply and the motor control board, and I've run and I'm running 6 volts of power in here from my bench supply, which is hiding way back here. I don't know if you probably can't see it very well. I tried 7.5 volts, which is the adapter value that's provided by the plug that comes with the elliptical. but that seems to overdrive things. The display gets a little crazy, and I guess I can show you the displays here on the other side. And then this is the connector for the keyboard. So what we can do is we're going to test this a little bit. So I did want to come back to the mistake I made when I connected this up for the first time. I was just looking at the silkscreen legend on here, and I saw it said VCC, so I ran my 7 volts in here, but this is not the VCC to power the board. This is the VCC out to the motor control board. Fortunately, I didn't damage anything. The screen came on, but the processor didn't run. So then I figured out, oh, V in is where the positive of the 7.5 volts has to go, and that's what's connected to there now. So don't make that mistake. So what I did, so I needed a way to jack into this thing. So what I did was I found this, I don't know, this is some junk from some computer, these plastic things, and I just kind of, I don't know if this is focusing well enough if I'm in the light there, but I just take these and cut them apart and get the metal barrel out, and then I put shrink wrap around it so I could actually use it to probe onto stake points, and I think it's going to be a nice tool to have using in the future. And anyway, and then this is connected to some alligator clips, which goes back over to the power supply. So if we flip this over now, we'll get this capacitive hand sensor out of the way. Make sure nothing's shorted. And how are we doing? Let's get that centered. That's good. All right, so now if I turn on the power supply here, and so there we are running. I don't know, can you see that okay? How's this light? Sorry, I don't have the best. It's a good light for working. It's not necessarily a great light for filming. I priced these console boards too. I guess you get the whole plastic console as a replacement. That's still available. They're like $300. So, I mean, if you can fix this thing without spending that kind of money for something that's so old, you know, that's a good deal. This board is made in, was it Suzhou, China, where all the contract manufacturers are, kind of east of Shanghai. So this is the back side of the connector where the keypad wires come in. So there's common here, and what we can do is now kind of test all of the functions without the keyboard, and if they work, that kind of shows that the control board is just fine. And I think what I'll also do, I may do it off camera, is I'll also connect up to the motor plus and motor minus, and make sure that when we run the motor up and down, it actually is sending voltage to the motor control board if it were here. So here's start stop, and so now he's starting. That's great. Let's raise our power here. This is the one that doesn't work. Oh look, works fine. Uh-oh, I turned the beep off. I hit the beep. See if I can turn the beep back on. Which one was that? Is it here? Oh shoot. Gotta get the ground here. Turn it up, 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 up. Down, 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 down. Let's stop. Can we stop? Okay, we stopped. Now we're starting. And we'll go down. Down, 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 down. So that's good. What's this? Enter. Okay, there's beep on. Good. And that seems to be fine, and that seems to be fine. And then these aren't really connected to anything. So it looks like all the functions are actually working if we had a keypad that was working. So that squarely puts the problem on the keypad, and that's the next problem we need to take a look at and address. Here, so I've been using the heat gun and just kind of going around and taking this up, and it comes up okay as it gets heated. And inside you can kind of, you can see this. There's a capacitive matrix and then a piece on top that matches it, and it looks like it kind of splits into two halves. I'm kind of leaving the bottom circuitry on, but over here is the one we're interested in, because this is the one we think probably doesn't work, although I should have tested that before I got into this. But so I'm just going to try to loosen this whole thing up. There's kind of a bottom piece to this. See, this is what worries me. I'm kind of splitting you can see this, I'm splitting the pad, because there's a true bottom, and then this is in two halves where the capacitive switches are. But we'll try to get it off and sort the bodies out later. Anyway, we kind of worked my way around here. This keeps going back down, but it's not. It's coming up okay. Oh, geez, I really don't even need the heat anymore, but I've been using it. This is 325 degrees or so, and just kind of softens things up and makes it a little easier to deal with. Yeah, should I be taking off the? I think I'll keep splitting this in half and leave the bottom piece in. I see that the board was made in June of 2006, so what is that, 13 years ago? 14 years ago? Okay, forget all the stuff I said about switch matrices and all that stuff. This thing is about as simple as it can be now that I can get in here and see a little bit. I hope you can see that. It really is. There's just a ground, and then each of the 6 switches has another wire here, and it's not capacitive at all. You're actually grounding this matrix on top of this matrix to make the connection, and they're just using the thickness of this pad for the button. So I mean, it obviously can handle a lot of sweat and moisture and keep working. Very simple. And then this ground goes to every single switch. So yeah, not capacitive at all. And so here we are with the whole top level pad peeled away. I did a little research today. These are non-tactile silver membrane switches, and there's a bunch of companies that will print these for you for your devices, although they're not meant to be taken apart. And they lay this trace down with a silk screening process. So that's what makes them silver instead of copper, and the silver is cheaper. And then I guess they use a conductive glue or electronic paint as well as part of this. And then I went ahead and I Xeroxed the front piece so I could know what the buttons are, because I keep forgetting without the legends visible. And I flipped the camera around because we're going to do this upside down because of the way the connectors work. It makes it easier. So what I want to do is test these buttons and see how they're doing. We already know that this one, the level up, doesn't work, but I think there's problems here too. So I have been beeping around in here. I have never been able to get continuity between these two. I can get it here, but not here. So I do think that this may be a problem. And I can get continuity down on some of these, but it may actually be this connector itself, which actually I've been abusing, because it's not meant to be put in and out so much. But anyway, we'll turn this. Let's see, how do I want to do this? We'll put this way, and we will pretend that this came through. Is that right? Let me think about this a second here. Get some of this junk out of the way. So this generally sits like this in there. Yeah, so this connects up here like this. I don't know, can you see this on the overhead? No, let me move everything over a little bit. So we're gonna go ahead and stick this ribbon cable in. Come on. So I don't wanna mess this up. There we go. Okay, so that's in now. Then we'll flip this around as though it were in the real machine. We'll stick it through the window, and this is why I turn the camera upside down. Let's see. So we can get that a little more centered there. Sorry about the glare. So there is this Lexan insulator, and most of it is on the piece I took off, but I did rip it, so there are a few little bits and pieces of it here. This is still very sticky, so I think it'll stick back together okay. If not, I'll probably put some rubber cement on it. So, okay, this looks good. Make sure nobody's shorting. Let's turn on the power. And now the easiest way to kind of test these, I just have a paper clip, and I'm just going to push down on it to see what works. So I think we'll have good luck over here with level down, so let's try that. Yep, no problem there. Start, stop. Okay, we're going. Stop. Let's try program select. Nothing, but that is, in this one, nothing. And up, nothing. And how about beep on, beep off? I think that works in it, yeah. So at this point, I think I've got 3 buttons that are a problem. This one, this one, this one. So after doing that test, I took the traces back under the microscope and probed around with the multimeter and discovered that the 3 circled areas you see here are not conductive anymore. I don't know what this is, maybe mold from some moisture from being out on the porch, but these 3 areas definitely are not conductive and are certainly the problem. Unfortunately, the one on the right, which is the one that goes to the level up button, is under the start of the ribbon cable plastic. You can kind of see the line of the plastic going across at the bottom of the brown stain, which is non-conductive. So the question now becomes how to go about fixing this, and I'm more convinced than ever that moisture came in where the ribbon cable comes in, and that's some kind of mold. And that probably made it easier for me to split the 2 halves of the pad apart. And indeed, if you're doing that, you should probably start at where the ribbon cable goes in, because that's obviously going to give you a place to wedge the 2 halves of a keypad apart. The smart thing to do, I think, for most people would be to get a bunch of waterproof push buttons like these. You get these on Amazon for $10, and they're like these little green domes here. And then just go ahead and drill and the reason I'm using the Xerox instead of the real piece of polyester is because the real one's all sticky and it sticks to everything all the time. But then you just drill a hole, and you could mount these above the legend or over here right on the arrows, and there's different colors, and then just take the ribbon cable connector off the main board and solder the wires right into it. You could make a disconnect if you wanted to get fancy, but that's going to be the easiest way for most people. But I want to try something a little different because I'm foolish. I'd like to try soldering this ink, because I've never done it or never seen it done. This conductive ink, and see if it's possible to kind of actually repair this. So I cut out the moldy part so that doesn't spread, hopefully, and I'll try to seal up the entrance of the ribbon cable when I get there. I found a website, a company called, I think it's Volterra, and I'll link to it at the bottom of this, that makes circuit prototyping equipment. You can actually print circuits with this silver conductive ink, which I don't know if it's exactly what's on this board, but it seems very similar. And then you want to solder components to that ink, and so they have some videos and a tutorial which I'll also link to. And the basic takeaway is that you can't use regular soldering temperatures like 700 degrees or 600, 650 Fahrenheit because that'll melt the plastic substrate. So you need a low temperature alloy, and then they recommend using a tin bismuth alloy with silver in it, and I'll put the exact formulation up on the screen. Now they sell a wire of that. A Kester looks like there's one in there with 245 series as well. I couldn't get those quickly enough. I want to get this project done and out of here, but I could get a solder paste, a low temperature solder paste with that chemical composition here, in 2 days with Amazon Prime. So that's what I did, and I'll show you what I'm doing here. Now I don't have a microscope camera, so I can't show you exactly. All I can do is take like the iPhone, put it close, and then zoom in. But I took a thin piece of hookup wire, stripped it, tinned it, and then put high temperature tape around it, which is probably overkill, but that's just to kind of hold it down and protect the plastic substrate a little bit. And then, and I understand I can't just use solder paste by itself to make these jumps if the videos I looked at are to be believed, because it just balls up. So that's another reason to use a piece of wire to kind of give the solder paste something to stick to. So I'm going to go ahead and put solder paste on this board and under the microscope, and then I'll hit it with hot air from the rework station at like 325 degrees Fahrenheit. It's supposed to be like 180 degrees C or 350 Fahrenheit, and so 325 at a low air temperature. And we'll see. This could be a huge failure, but if it works, then I can redo these bad traces and seal the whole thing up. And in theory, you won't know I've been in there, except maybe for some bubbling where the thing doesn't go together. But let's find out. All right, so everything's back together. If I look all sweaty and awful, it's because I just spent an hour assembling the mechanical bits, and they required some persuasion with the rubber hammer. So you're ready to see my great success with the new console attached here? Let's take a look with this camera. Oh no, what are those? There's buttons there. What happened? Well, yes, we had a little failure. So I burnished up the contacts with the nylon scrubby, and then I laid down a thin piece of wire and taped it down with high temperature tape there, and soldered it up, hit it with the paste, and then hit it with the rework gun, and the solder balled up, but it actually did work. It made a good electrical connection that stuck to the trace, so then I knew I could solder it. So I was really happy, and I went on to do the second one, and at that time, when I hit the heat for the second one, the heat spilled over and unsoldered the first one because the temperatures are so low, which was kind of a disaster. So I said, okay, well, I'll lay out all the wires at once, put solder paste on everything, and then hit it with the rework gun at one time. And in that way, we'll solder everything at once. So I laid out all the little pieces with a bunch of little tape, and it looked really good. And then all I had to do was take the gun and heat it all. But I lost my nerve. I thought, well, maybe I'd have more control if I use my soldering iron. Well, these Takeo irons only go down to 400 degrees, and we need to solder at like 350, ideally 325, which is what I had the hot air at. But I noticed that the temperature when I turned the iron off, I noted when the temperature was falling, it went down 50 degrees every 12 seconds. So I turned off the iron and counted to 15 or 20 and went ahead and tried to solder it. Big mistake. The iron was way too hot. The silver migrated into the solder, lifted the traces entirely off the board, off the plastic, and the whole thing was pretty much ruined. So that's why we have these fine buttons here. So I went ahead and drilled 6 holes in here, stuck the buttons through, figured that I didn't have to put a nut on the back because they fit really tight anyway. The hole was pretty exact at 7/16. Soldered it all. And then this high-speed thing I'm showing you now is going to show you me assembling a whole case and putting it together, but the iPhone ran out of storage because it turns out when you delete a long video, you have to actually go into settings to make it really, really go away. So there wasn't room. But anyway, assembled that, put it all together, and here we are. Does this kind of stuff ever happen to Mr. Carlson? I don't think so, but you know. So here we are. The controller is working great. So let's see what we do here. What is it? Program select. What do we want to do? Want to do uh-oh. What did I do? Did I pick something? Better stop. Let's stop. All right. And now we're going. Whoop. Whoa, this is like exercise. Jeez. And level up works now. And you turn the beep off. And you can turn the beep on. Oh, my goodness. And you can stop. We'll do the... Anyway, so the controller's working great and it's putting out the right voltages, but now I find that the damn motor isn't turning. So, you know, it's one thing after another. I'm going to leave this put together because they have to move it. They're changing stuff around here. So I guess this has been a failure all around, although the controller is beautiful and working great. And we'll just have to come back to this part 2 at some point in the future. But for now, I'm afraid it's just complete and utter abject failure. YouTube is a soul-crushing endeavor, let me tell you. Anyway, for now, why don't you take a look out here at the beautiful trees. Oh, isn't that nice? Inhale. And if you enjoyed this litany of failure, please give me the thumbs up, like, subscribe, ring the little bell, watch some of the other videos, have a beer. Thanks for watching.